Okay, so we're going to have a little look at integration today. Now, integration is the exact opposite of differentiation. So instead of taking away one power, we actually add a new power. Now, integration is a posh way of looking at the area underneath a curve. And obviously, it's using algebra to look at the area underneath the curve. So the first example we are going to do, that is the integration sign, that sort of curly S at the front. And it doesn't have any limits on it. So if we have a look at the one underneath, it has numbers on it. This one doesn't, okay? So this is the very first type, the basic type, and if you look, it's worth 4 marks, okay? So we are thinking about integration. So we would say the big 4 is going to stay the same, x is going to stay the same, and I'm adding 1 to the power, so 6 plus 1 is going to give me 7, and I also divide by my new power, so I divide by 7. Now this part, okay, this bit here is a fraction. Now at the moment I actually can't do anything with that, and using your laws of indices, 1 over anything is the same as writing it as a negative. So that's what it actually looks like without using fractions. So I can say x. Now if I add 1 to that power, so minus 2 plus 1 gives me negative 1, and I divide by my new power, that's minus 1, plus 9. Now I'm adding a power, so I'm adding in that x, so that's what it becomes there, and it's like an x to the power of 1, so you divide it by 1. And with integration, we put plus c on the end. Now that accounts for something called a constant. That means where the graph would be cut in the y-axis if you were to draw it out. Okay, so like in your normal graph, you'd see y is equal to mx plus c. That's what that plus c is representing. It means if I was to draw this graph would cut the axes at some point, and that letter represents where it would happen. Okay, now you don't actually have to do anything now. That is the answer. If you did want to tidy it up a little bit, you can, but there is no expectation for you to do so, okay? So I will just show you. That one's going to stay the same. Now this one here, obviously, you could write it as a negative if you wanted to, so negative x to the minus 1, but you don't have to. And then plus 9x plus c, okay? So obviously 9 divided by 1 does give me 9, and that plus c stays on the end. Now that is called an indefinite integral. It has no limits, no numbers on the integration sign, so your answer is still going to be left with loads of algebra and letters in it, okay? The second type of integration is the one that can be found right underneath. Now, if you look, that's actually worth more marks. That is worth 5 marks. It tells you that compared to this one, there is going to be some kind of extra step, some kind of extra thing you have to do in your method. So the integration process is going to be exactly the same, and then we will deal with the limits, those numbers, at the very end, okay? So if we look at this one, we are thinking about keeping the 3 the same. X, I'm adding 1 to the power, so that is a 2 at the moment, that now becomes a 3, and I divide by my new power, so I'm going to divide by 3, plus 1x, so it will be to the power 1, over 1, and I don't have to put the plus c in this time, okay? Now I'm going to use these boxed brackets, and this just indicates that my integration has limits, has those numbers on it, and I'm going to place those numbers on the outside. So this is called a type of notation. It's used at A-level maths a lot, so you will see it next year a lot. This bracket is obviously not a round bracket. It just indicates that you have numbers, you have limits on your integration, so you're not quite finished. That's really what it's telling somebody. Now we're going to sort this out a little bit first. So 3 divided by 3 is going to give me 1, so I don't have to write that. So I've got x cubed, you can put the 1 in front of it if you want to, plus, obviously 1 divided by 1 is just 1, so I've got that plus x on the end. Now I'm going to put those in my square brackets and put my limits on the outside. Now all that means is I'm going to substitute, I'm going to replace my letters with that number 2 first, then I'm going to replace my letters with the number 1, and I'm going to work out the difference between those two answers. I'm going to take them away. So next line, I would have 2 cubed plus 2. That would be what happens if I replace those x's with that number 2. I'm taking away, and it's always taking away, you are finding the difference between those two values. What happens when I put 1 in there? So I've got 1 cubed plus 1. Okay, we're just going to calculate those, we're going to work those out. You do have a calculator, by the way, but these are quite nice numbers anyway. So 2 cubed is 8, plus 2 is going to give me 10. Now my advice would be, don't worry about the taking away yet, work out what's inside the brackets first. The reason for that is if you have more complicated sums, it can get you into a mess with all your signs. So I would work out what's inside the brackets first, a bit like BODMAS, work out your brackets first. So 1 cubed is just 1, plus 1 is going to give me 2. So my answer now is 10 take away 2, So that's going to leave me with a solution, an answer of 8. And that is integration. Okay, now the only way, and I have seen it a few times on the additional maths, that they can make it a little bit harder, is by introducing the graph. Okay, now the actual principle of integration is exactly the same. So if you look, they say the diagram shows a sketch of the curves. They've given you the algebra, and it's also repeated down there. So that's our equation. So that is exactly like the ones that we've had up here. And they've also, on the graph, if you look at the bottom, given you the limits. So if you wanted to write it as an integration question, it would look like this. You'd have 3x minus x squared, and it would be between 0 and 3. So all they are doing is writing that on the graph for you and expecting you really to do that intermediate step, that step in the middle. Now we're going to integrate, do exactly the same as we would normally. So we're going to think about 3x, add 1 to the power. So that's 1 on its own at the moment. If I add 1 onto it, I get 2. Divide by your new power. That's also dividing by 2. Take away x to the power of 3. That is 2 at the moment. If I add 1, it turns into a 3. Divide by 3, because that's your new power. Chuck in those squared brackets, just to indicate you've got those numbers, those limits. You can have 0 and 3. Okay, exactly the same principle as before now. We are now going to substitute in our values. Okay, so I'm going to put 3 in there first. So I've got 3, which is out in front. Then I'm going to replace my x with my number 3. And then I'm going to divide it by 2. Then take away 3 cubed over 3. And don't forget to box them off. Finding the difference, that's why your takeaway is important. Now I'm going to substitute 0. Okay, now this will make it very nice, because you will notice that 0 times by anything will make 0. Okay, so I've got 0 cubed, take away 3. So those are my 2 solutions there. Now if you notice, everything inside this bracket is actually going to disappear. Okay, you've got 0 squared, so 0 times 0, which is nothing, times in by 3, which is also nothing, and then dividing by 2. So actually, that whole bracket on the end will become 0. So I don't actually need it. It's this bracket here. This is the one that I am actually interested in, okay? So what I would advise you doing, I'm going to carry on going down here. We are going to think about simplifying what's inside those brackets. You do have a calculator, by the way, okay? So we've got 3 squared, which is going to give me 9. And you divide in by 2. 3 times 3 times 3. So 3 times 3 is 9. Times 3 again is 27. That's also dividing by 3, okay? Then we're thinking of 9 times 3, which is 27 divided by 2. Take away 27 divided by 3. And you are allowed a calculator. Okay, so please don't be frightened to use that calculator, particularly in a situation like this, where you now have fractions and you've got to take them away from each other. Now, if you do chuck that in your calculator, you do get an answer of 9 over 2. You can leave it as 9 over 2, or you can write it as a decimal if you really want to. Most of your calculators will probably give it to you as a decimal, but you can turn it back into a fraction. And that is integration.